Okay, so we're going to move on to patterns in farming. And we've seen that over time, farms have gotten bigger on average, and there is a lower number of farms. So we have fewer farmers overall, and the farms that still are around are much larger than they were in the past. So we can see that in this graph here. It goes from 1950 to 2000, and we can see in 1950 we had 5.38 million farms, and we had less than half of that by the year 2000. Whereas in 1950, the average farm size was 213 acres, and by 2000, the average farm size was 434 acres. So we have less than half the number of farms, and those farms on average are about twice as big. So we've really kind of pushed small farmers out of the equation and favored larger industrial scale farms. In developing countries, there are still a lot of small farmers feeding in to the food economy. So some of these farms are so big, they're considered to be mega farms, and they are highly mechanized, lots and lots of equipment, and just a few people working, you know, hundreds of thousands or 100,000 acres, or even tens of thousands of acres for many of these farms. The biggest ones, I believe, are around 150,000 acres, but you can look up some footage of some of these farms, but they've kind of deemed them mega farms. And so I linked an article if you'd like to read about this model of intensive farming and how it's becoming more prevalent worldwide. So this also looks at the U.S. Food supply chain. And so if we look at the major freight hubs, we can see that there's a couple of directions that food are going between different locations. And then if we link in it from a county by county area, we can see some different patterns. But in general, a lot of this is concentrated in the middle of the country where that's our grain belt. We have so much agriculture going on that you can see that in the food supply chain. You can also see a substantial amount in California, and we probably all are familiar with the fact that California also does produce quite a bit of food. So we're doing this intensive food production. We're converting land to soy and corn production that goes to feed animals. And all of this increases soil erosion, which we'll talk more about in the agriculture chapter, which is next. In these concentrated animal food operations, there are some byproducts that are problematic. What do you do with the manure? So this is an example. This is a chicken farm. You can see the houses that have high numbers of chickens in each of these houses. And there is a waste pond here that contains all the waste from this operation. And then you can see sometimes there's flooding or there's a hurricane that comes through and causes flooding. And this is the same farm, and you can see that all that waste, animal waste, is now mixed in with the floodwaters, and that is very hazardous. If somebody has to touch that, they can get very sick from any kinds of pathogens that are mixed in with that. There's very high levels of nutrients. This is not good for our water quality. We also see that in a lot of these, they're using a lot of antibiotics, as we talked about before, and this is leading to more antibiotic resistant pathogens. So if we're continually giving farm animals antibiotics that we also want to use on people, and the different pathogens are becoming resistant, it's more likely that we're not going to be able to treat people adequately when they get sick, because our antibiotics won't work as well, or they may not work at all for certain strains of certain pathogens. Another question about what do we do with the manure. This is an example. This is showing it being sprayed on a field as fertilizer. And so that is one thing that is being done with some of it. So also think about some other problems with how we're doing this. What are some shortcomings of the Green Revolution? So Green Revolution plants, as we talked about, this is kind of the technological advances that started in the 1960s to increase global food production. So most of the plants that were either hybridized or designed are considered to be high responders. So they show increased yields, but only under very specific conditions. They usually have to have fertilizers, and they have to have some sort of protection from pests, or they don't respond well at all. So this graph shows yield on the y-axis and a fertility or water gradient on the x-axis. And it shows that these Green Revolution crops do really well and they have very high yields, but only on a narrow set of conditions. So if they don't get the right amount of water, or if they don't get the right amount of nutrients, we can see their production is very low. Whereas more traditional varieties of most crops might have an optimum at a certain amount of fertilizers and water availability, but it's much more gradual. If the water is a little bit off, the production is just a little bit lower as opposed to dramatically lower. And so that's a big difference. If farmers can't afford these fertilizers, or if we're having a drought year or something like that, these varieties may not perform very well across these ranges of conditions, whereas the traditional varieties are more likely to be still producing when we have different weather patterns, or if we can't afford fertilizers, or we don't have expensive irrigation systems. So poor farmers often cannot use these methods, even though they're being sold as if they are the only methods. So many poorer farmers can't afford fertilizers, pesticides, and the seeds that they spend a lot of money on might not do as well. It's also important to note that the nutritional quality of some of our crops has been changing over time. So there's a variety of reasons for this. And this article here is fascinating, but it is very long. But I copied it in here if this is something anyone is very interested in. So one thing we have happening, we haven't talked about climate change or greenhouse gases a whole lot yet. But most of you probably know that carbon dioxide has been increasing in the atmosphere, and that is a greenhouse gas. But carbon dioxide is also what plants use in photosynthesis to create sugars. That's how they grow more of themselves or grow seeds to reproduce, and that's what we're harvesting from our crops. So when you increase the amount of carbon dioxide in the atmosphere, plants can do more photosynthesis. It means that they have more carbohydrates, but it usually means that they have less of other nutrients. So the amount of iron or other things that we need from our food is going down in concentration in our food while they're producing more. So if you eat the same amount of spinach, it's going to have less of these nutrients that we need, because it's grown a bigger plant from more carbon dioxide, but the amount of nutrients in the soil is the same. So that's a big part of it. We've also been selecting for plants that grow larger. So we've been creating varieties that are bigger and bigger, but often the nutrients in the soil, especially the micronutrients that we need, are not increasing. So we're getting less nutrient concentrations in the same, also from just selecting for higher yields. So this means that our food is not as nutritious as it used to be. And the variety of food that we're eating does matter for that. And so that's an interesting kind of side note about nutrition and the food supply. So I also want to talk about kind of where our crops came from. So a lot of people think that the food we eat just existed naturally. And they certainly do come from wild species that some of which are still around in native ecosystems. But we've selectively been breeding for around 10,000 years, maybe longer than that. And over time, we've basically created these fruits and vegetables from something that wasn't nearly as nutritious or as abundant producing as it was being selected just in nature. So this is what teosinte looks like. This is the wild original version of corn, basically. This is what was around in native ecosystems in Mexico and Central America, and they selected over time for corn. And so you can see that these two things look very different. They're very different in size, and this one's a lot sweeter and easier to eat. So we've really changed what these plants look like, and that's how humans have been manipulating plants to eat for a very long time. Another example here is this is wild mustard. It's one species that's been transformed into many, many, many different crops just by selectively breeding this one species and choosing plants for particular traits to then go on and keep proliferating. So over time, you keep selecting for certain traits that you like, and then eventually you get a vegetable that you want to eat. So this is kind of crazy sounding, but cabbage, Brussels sprouts, kohlrabi, kale, broccoli, cauliflower, and then it doesn't show bok choy, and a few other ones are all, it does say cauliflower, are all the same species. They look really different, but that's because different groups of people selected for different traits. So for cabbage, they selected for terminal buds, Brussels sprouts selected for lateral buds, kohlrabi selected for the stem, kale for the leaves, and broccoli and cauliflower for the flower clusters. And so they got very different crops by doing that, which I think is kind of fascinating. But these are natural, are not things that existed out in the wild. These are things that people created essentially through selective breeding of these plants.